Let me check out the mic. Say something so I can know. I need to hear.
I can hear you, sir.
Morning, sir.
Morning.
Morning, sir.
Hey, Nelson, what's good? Nelson, are you doing that, Matt? Or you just like learning?
Just learning something new, sir.
Okay, good. All right, cool. All right, let's see if I can get you out to this special screen. All right, so this is the problem I'm going to be looking at today, right? And it's pretty similar to something that you girls are working on. So we're given a cubic function, and the cubic function is y is equal to minus 2x cubed minus x squared plus 2x. All right, so let's just get out with that. All right, so you want to have your notebooks with you because we want to go step for step together, okay? Minus 2x cubed minus x squared. I believe it's plus 2x. Okay, and what it's asking us to do is asking us to find the tangent to this point when the curve is equal, when the curve it touches the tangent at x is equal to 0. All right, so let's just put this into perspective first of all, right? Let's just put this into perspective first of all. So what's happening here is that we have a curve. Now this is a S curve. This is a cubic curve. Okay, this is a cubic curve. Notice that it has a 3 there, right? So our highest power is 3. So that makes this a cubic curve or a third degree polynomial, right? A third degree polynomial. Because the highest power is 3. Because it's a third degree polynomial, it's a cubic function. Okay, so we're looking at cubic functions, right? And there's certain things that we know, we ought to know at this point, right? So if it were a quadratic function, it would look something like this or like that. And we could do some transformations to let it go like that, but basically you have a U, upside down U, right side up U, sideways U's, whatever. This is a quadratic, right? So because we have a cubic function, we have what we call a S curve. So this is one way a S curve might look a sideways S, it could look like that and so forth and so on, right? So it's an S curve. So in an S curve, when you have a tangent, excuse me, you could touch multiple points, okay? So it could touch multiple points on this curve, okay? So in this problem, what you're being asked to do is find out at what point and what is the equation of the line, the tangent line that touches this curve when x is equal to 0. All right. So again, let's just say this curve looks like this. All right. So a tangent comes in, okay, and touches this curve. And let's say at this point, x is equal to 0. What you're being asked to do is find the equation of this tangent line. All right, that's what you're being asked to do, to find the equation of this line. Now this tangent line is just that, it's a line. Okay, so it's a linear function. And we represent linear functions, lines like this, y is equal to mx plus c. So we're looking for something that looks like this. So our answer has to resemble this. Our answer when we're done with part A has to resemble this. Okay, so what's the importance of this right here? Because a tangent could be here too. A tangent could be here too. A tangent could be anywhere, but this is telling you which one of the tangents we're looking for. We're looking at a tangent when x is equal to 0. Now this could be given to us in different ways, right? So we could say at the origin, yeah, x is still 0, right? At the origin, x is 0. The good thing is if they give you a point, remember a point comes in a form xy, right? So if they give you a full point, now you have the x and y value, okay? In this problem, they don't give you the full point, but that's okay. We could find a full point. So all I did so far was give you an understanding and appreciation of what is being asked of you in part A. Okay, that's all I'm doing so far. We haven't started to work this problem yet, okay? So let's move it. Let's start to work this problem, all right? So I'm gonna erase these. Hope you have your notes with you, but remember, you can always communicate with me. I can always undo whatever I just did. If you are writing that and I erased it beforehand, just let me know. I can undo that and get that right back, okay? So here's what we're gonna do. Our goal is to end up with an equation, mx plus c. One of the things we can do by differentiation is we can find m, right? So if we differentiate the original function and put the x value in there, the answer we get is the m of the line that we're looking for. So let's do that. Let's differentiate, right? So differentiation is dy dx, and we could write it like this. Y prime here is going to be minus 6x squared minus 2x plus 2. Now, how did I get that? When I differentiate, what I'm going to do is I'm going to start with the first that I have, right? This is my first term, okay? I'm going to go to the power. The power is 3. I'm going to take it and multiply it by whatever the coefficient is. That's how I got minus 6. And then I'm going to subtract 1 from whatever the power was. So if it was 3, it will now be 2. If it was minus 1, it would have been minus 2. Okay, whatever the power was, I'm going to subtract 1. Okay, so that's what I did in the first term. And I did the same thing here. So the coefficient here was minus 1. We don't see the 1, but it's there. And the power is 2. So I take the power and I multiply it by the coefficient. Now that minus 1 becomes minus 2. And then I subtract 1 from the power. So it was 2, now it becomes 1. So again, you don't see the 1, but this is really x to the first power. And I got 1 there because I subtracted 1 from 2. Okay, so that's what we did. And then when we get to something like this, all I do is I'm going to take just the coefficient. But it still follows the rules. The fact of the matter is this is 1, isn't it? This is x to the first power. 1 times the coefficient here is 2, right? Because the coefficient is 2. And then I subtract 1. So I get 1 minus 1. So I'm going to get x to the 0 power, which is 1. Right? So the truth of the matter is this is how we differentiate. All right. So I've differentiated, and as I mentioned to you before, in order to find m by differentiation, what I have to do is first get the first derivative and then evaluate at the point where x is, right? So let's say they had told us that x was 4. Then I would evaluate. What do I mean by evaluate? So if I have f of x is equal to 2x plus 5, and I want to evaluate this at 2, then I would say f of 2. What that means is I'm going to pass 2 through the function. So wherever I see x, I'm going to put 2. So I'll say 2 multiplied by 2 plus 5. So f of 2 is 4 plus 5, which is 9. I have evaluated this function at x is equal to 2. Okay? So now, going back to what we're doing here, first, I get the first derivative. So I differentiate. Now I'm going to evaluate that derived function, that first derivative, right, at x is equal to 0. How did I determine 0? They told me that. They told me by saying x is equal to 0. They could have told me by giving me the exact point, 4, 5, right? If they had given me 4, 5, says that this is where the tangent touch the curve, then the x value is 4. So I would evaluate at 4. If they had said the origin, they put no points here, they'll say the origin. We all know the origin is 0, 0. We're looking only for the x value, okay? So pay attention to how that is given. It could be given in multiple ways, all right? So what's gonna happen here now is we're gonna evaluate at 0. Remember, what we're gonna find here is a number that is the slope. That's what we're finding here. So now I evaluate, so I say y prime, which is the same as f of x, right? Of 0. And what that means is wherever I see x in this function, I'm going to put 0. So I say minus 6, 0 squared, minus 2. And wherever I see x, what do I put? 0 plus 2. So I don't care about the square and I don't care about the coefficient y because I'm going to be multiplying by 0. So this is 0 minus 0 plus 2. Hence, when I evaluate this at 0, I get 2. So I'm making progress, right? Because now I know this is what? What did I just find? We can't lose focus of what we're doing. What did I just find? I just found m. So I'm one step closer to my answer, right? Because now I have y is equal to m. I have discovered this too. So y is equal to 2x plus c. So all I have to do now is find c. So I'm back now to that second format, right? That basic stuff now, right? The differentiation part is over, okay? The differentiation part of this is over. All I gotta do now is find c. But in order to find c, what would be awesome is if I had a value of y to put in and a value of x to put in. And then my only unknown would be c, right? Truth is, if I could just find out what y is when x is equal to 0. Remember, if they had told us origin, I would have known what y was, right? Because origin is 0, 0, so I have x and y. If they had said 4, 5, I would have known what y is. So I could have plugged it in here, but they did none of that. None of that in this particular case, right? So I gotta go and find y. So how do I find y? I have to put in the x value into the original equation. Okay, so now I'm going to evaluate the original equation at 0. All right, so let me just erase this right here. I'm hoping you guys are taking notes. What I'm going to do is I'm going to post this on the other pages, the Facebook, the IG, and the YouTube as well, right? Just in case you want to rewind it or whatever. All right, so now what we're going to do is we're going to find the y value, right? So I'm just going to write that in there, just so you know what we're doing, right? We're finding y when x is equal to 0. So this is the original function. So when x is equal to 0, what I'm actually going to do is I'm going to evaluate this function at 0. So this is going to be minus 2 times 0 cubed minus 0 squared plus 2 times 0. So what do you know? This is 0 minus 0 plus 0. So this is 0. So the point 0, 0, the origin is in fact on this line. You see that? So when x is 0, y is also 0. Now, I'm going to erase this right here because we're done with this. So this should be in your notes because you need to know the steps that you need to follow, okay? All right, so I'm going to erase that. If you're not ready for me to erase that, just say something, okay? I'm done with that. I'm done with this purpose. This purpose has helped me find y. And I'll remind you that the reason I needed a y value is because that's going to help me to find c. All right, so now, when y is 0, x is 0. Therefore, c is equal to 0, right? So this is just algebra, right? This is 0 is equal to 0 plus c. So c is equal to 0. So now I'm going to go one step farther from here. Now I have a value for C. So y is equal to 2x plus 0. But we don't write it with the 0 on there. We just say y is equal to 2x. This is your answer right here. This is your answer to part A. Okay, there is no fancy way of writing that. The equation of a line is written in the form y is equal to mx plus c. If I see this as a teacher, I'm thinking c is 0. I'm thinking this is what the student is telling me. And in fact, this is correct. So we have found the equation of a tangent to a curve, a cubic function, where x is equal to 0. That's what we did. Okay? That's part A. And that's how you do it step by step. Now, the next part of the question, part B, is asking us, at what other point on this function does this same tangent meet the curve? At what other point? This is where we move away from calculus to algebra, but on a higher level. Okay, still a high school level. You are responsible for what I'm about to tell you at the CXC level. Okay, all right. So conceptually, I'm going to show you what it is that we're looking for, right? So first of all, let me just write what we found out in part A. In part A, we discovered that y is equal to 2x. All right, now conceptually, right? So let's just say this is your S curve. And let's just say you had a line that met this curve at 2 points. This is 1 point, and this is another point. It's asking you what other point, if any, does this line, y is equal to 2x, meet the curve? That's what it's asking you for. What is your answer going to look like? It's asking for a point. Your answer is going to look like this. A coordinate looks like this, x, y. That's what it's asking you for, an XY point. It's important to know what a question is asking so that when we write our answers, we have a good idea of are we on the right path or not. So this isn't a part of your work, and this is a part of what should be going through your mind. All right, so let's boogie, let's do this. So if I have two lines, right? I have a line that goes there, I have a line that goes here. Where these lines intersect, right? Let's just say one line is f of x, another line is g of x. They're just functions, right? They're still y is equal to something and that's right. Where these lines meet, these functions are equal to each other. So wherever these lines meet, f of x is equal to g of x. Now, conceptually, what is that saying? That is saying that at this point, let's just say that at this point, we have the coordinate is 2 and 5. Let's just say for argument's sake, at this point, right? It means the point 2,5 is on this line. It also means that the point 2,5 is on this line. That's what's happening conceptually. This point is on both lines. Remember the point we just did just now, the origin? We discovered that the origin is on this line. It's on this curve. The origin is also on this curve because they meet at that point. That's what we discovered. We didn't ask that in the question, but that's what's happening here. There is another point, the question is suggesting, that is on both of these lines. So how do we do that? First of all, we should be happy that we know what we're looking for. We're perfectly in order in what we're looking for. Okay, let's boogie, all right? How do we know what to do here? They must be equal. So minus 2x cubed. Was that the question? Was it minus 2x cubed? Or was it x cubed minus 2x squared? What was it? Let me just double check.
You have it correct, sir.
I have it correct? Okay. All right. So minus 2x cubed, the minus x squared plus 2x, this is kind of like one function, right? Is equal to 2x. At what point or points are these two functions equal to each other? Now I got to solve. This is where algebra comes in, right? This is where everybody should be able to boogie, right? So what I'm going to do is I'm going to say, okay, let's keep this as it is for right now. And I'll show you why I'm doing this. This is minus x squared. This is plus 2x. But now I'm going to bring this 2x over. I'm going to transpose it, right? And when I transpose this is positive, so it becomes negative on this side. And this is equal to 0. I subtracted 2x from both sides. First thing I realize when I do that is I realize that these two cancel themselves out. 2x minus 2x. Why do I do that? I'm inclined when I'm solving equations to put all variables on one side of the equation, right? And then try to solve. I have different methods in which I can solve, right? Depending on what type of problem it is, okay? So these cancel themselves out. So what I'm left with is minus 2x cubed minus x squared is equal to 0. All right, and that looks like, how on earth am I supposed to be responsible for that in high school? We don't really learn how to deal with cubic functions in high school. But pay close attention here. What you do learn is how to factor, right? And if you factor the x squared, there's an x squared in here and there's an x squared in here. So if I factor the x squared from this, I'm left with minus 2x. Agree, disagree? And if you agree or disagree, if you're uncertain, all you do is multiply these two back and see if you get this. Minus 2x multiplied by x squared is minus 2x cubed. So I'm doing something right here. And then this now becomes minus 1. Is equal to 0. Now you're supposed to be able to handle this. Because the truth of the matter is when I have two things multiplied by each other to give me 0, what I have been taught, and if you haven't yet, you will be taught right here in third form or maybe in fourth, but you have to be taught this. We don't know which one is 0, but one of them has to be 0. If two different things multiply by each other give me 0, one of them must be 0. There's no way we could multiply two non-zero terms and end up with 0. The fact though that we're dealing with variables, we don't know which one gives you 0. So what we do is we set each of them equal to 0 and we solve. So what we're going to do here is we're going to say x squared is equal to 0. And then we're going to say minus 2x minus 1 is equal to 0. And we're going to solve. So clearly when we solve this, we'll get x is equal to 0. And clearly when we solve this, we'll get minus 2x is equal to 1. So we transpose this over here, so it became positive. Hence, x is equal to minus 1/2. So those are the two x values for which these two functions are equal to each other. Okay, those are the two x values. So in order to find a point, we need a y value as well. Check this out. We already did y of 0, which is f of 0, right? In here, we already did that, right? And we got 0, but we could do it again. If you put a 0 here, this whole thing becomes 0. You put a 0 here, this whole thing becomes 0. You put a 0 here. So the fact of the matter is, if we use this function and evaluate it as 0, you will get 0. If you evaluate this function at 0, what do you get? 0. So the truth of the matter is f of 0 is 0. So 1 point is 0, 0. Oh, but we discovered that already. Remember that? That's what we did just now. We're looking for the other point, right? So the other point now needs to be evaluated at minus 1/2. So we're looking at f of minus 1/2. And when I put it in here, I'm supposed to get the same answer as when I put it in here. And you want to trust me when I say that what you will get is 2 times minus 1/2 is minus 1. Hence, when x is minus 1/2, y is minus 1. So minus 1/2, comma, minus 1 is the point, the other point where these things meet. Now, what I'm going to do is I'm going to just show you what I would have done there so you can do it on your own, right? To find that, all you have to do is come in here and say, so y of minus 1/2 is equal to minus 2 times minus 1/2 cubed minus 1/2 minus a minus 1/2 squared. Remember, x is minus 1/2, right? So wherever I see x, I put minus 1/2 plus 2 times minus 1/2. That would give you the y value. And it will give you the same answer in the both. If you put 2 times minus 1/2 here, you get minus 1. So when x is minus 1/2, y is minus 1. So the other point is minus 1/2 and minus 1. Let's review right quick what I did there. Let's review right quick what I did there. I'm not going to write this, just also giving you time to write this, but I want you to pay attention to what I did there, right? Pay attention to what I did there. So I had to equate the functions in order to find the point or points where they meet / intersect. That's how I find points that intersect. Meeting is another word for intersecting when it comes to graphing. When I equate these functions, I found 2 points, 0, 0, and minus 1/2 and minus 1. Turns out I had already found 0, 0 in the first part of this problem, and it's asking for the other point. The other point is minus 1/2 and minus 1. Good, we're settled there. Let me review another part of the problem. How did I find minus 1/2 and minus 1? When I equated them, I had to go to my algebra skills. My algebra skills said to me, you need to solve, which means I want 0 on one end and the variable on the other side. So all I do before I convince myself this is going to kill me and pull out all the hair from my head, I just start writing. This is the function and this is the other function, equate them. That means put an equal sign. I'm one step closer to the end and I haven't died yet. And time hasn't gone while I'm killing myself with stress in my test. Once I equate them, I realize that my algebra skills and experience of what I need to be doing now is solving, however I could solve. Don't get thrown off by the fact that this is a cubic function. Let's just see where it takes us. When we did that, we realized, oh, look, we find a spot where we can factor out. I didn't have to use a quadratic equation. I didn't have to use a quadratic formula. I didn't have to factorize. I didn't have to do any of that wonderful stuff. It factored out nice and easy like a Sunday morning for me. Now I have 2 things that when multiplied together gives me 0. Okay, they're variables. So I don't know which one is 0. So my algebra skills says to me, equate them both to 0 and solve. That's how I got 0 and minus 1/2 for the 2 possible values of x. To then find the value of y, I substitute that value of x into the function. Any of the functions would have worked. I showed you in both to show you how certain I am that this would work. All right. So there you go. That's it. Any questions before I get off this thing?
Sir, so the answer is negative 2 1/2, negative 1/2 cubed minus negative 1/2 square plus 2 negative 1/2 for B?
No. This isn't the answer. This, when you work this out, will give you -1.
Oh,
This is what we do to find the y value for when x is -1/2. This is your answer. This is finding the y value. We earlier found the x values. Remember, we always want to start by understanding what's being asked of us. And from the very beginning, we should have known that what we're looking for is a point. A point comes in the form x and y. Nothing else will be your answer. No words, no paragraph, nothing. Your answer will look like this because we're looking for a point. If we're looking for an equation, your answer will look like this. We were looking for a point here, so we needed to find our point. The first half of the problem, we found our x value. To then find the y value, we substitute that x value into the equation. I didn't finish working this out because I figure you guys can handle that part. But when you finish working it out, you will get -1. Hence, the y value is -1. So this right here is your answer. This is a point. You're looking for a point. The point is -1/2, comma, -1. That's the coordinates of the point in this particular problem. Talk to me. All good? Anybody else?
Okay, thank you, sir. I understand now.
Awesome, awesome.
Same,
Nelson,
sir.
talk to me. Elena, talk to me. You were saying something?
I said same.
Good,
I
sir.
understand now. I more or less get the concept and the idea on how to do it.
Okay. Nelson, talk to me.
Good, sir. Clear up some stuff.
All right, awesome, awesome. How's the weather out there in Cayo?
I'm in
Cool.
Bulacan and it's cold.
All right,
It's not that cold. The sun is out, but still chilly.
okay. Haley, talk to me.
Sir, just left a Ghana bathroom.
All right. And you, what do you think? All good?
Yes, all good now. Thanks, sir.
All right, you guys have a good day. This is where I'm gonna stop. Like I said, I'm gonna be posting this on the YouTube page. So if you want to go back and look at it again, that's fine. All right. Enjoy the rest of your day. Take care.
Thanks.
Bye.
Bye, sir.
Have a good one.